Hey student, how are you? Welcome to our session on solving sinusoidal equations. In order to solve a sinusoidal equation, we need to use inverse sine or arc sine. And in order for the sine function to have an inverse, we need to restrict the domain so that it is 1-to-1, so that it passes the horizontal line test. If we use the entire domain, it is not 1-to-1, doesn't pass the horizontal line test, we hit more than 1 point. So we will restrict the domain of sine from -90 to 90. Restricted domain. And then the range is -1-to-1. Inverse sine switches the domain and range of the sine function. So our domain, our inputs, we can take inverse sine of any value between -1 and 1. And then our output will be an angle from -90 to 90. In order to find all the solutions to our equation, we will need to use other properties of sine. Let's take a look. Number 1, find all possible solutions to the equation. Sine of x is equal to 1/2, where x, what we're solving for, is an angle. In order to solve, we need to take inverse sine or arc sine of both sides of our equal sign. Inverse sine or arc sine. And we'll make sure that we are in degrees in our calculator. Inverse sine and sine cancel out, and we're left with x is equal to arc sine of 1/2. And we get x is equal to 30 degrees. We see here that 30 degrees on the unit circle, we get sine of 30 degrees is equal to +1/2. Now, we can find other angles for which sine is equal to +1/2. If we go all the way around the circle, 360 degrees, we will end up back here at this point. So we could do 360 degrees, 30 plus 360 degrees, we get another angle, 390 degrees, for which sine is equal to +1/2. Then we could go around the circle again and find another angle, and we get 750 degrees. So in order to generalize, we'll do x is equal to 30 degrees plus 360 times n, where n is the number of revolutions around the circle. Number of revolutions around the circle. So you could use n is equal to any integer. You could go negatively around the circle as well. Get back to that point there. Now, let's take a look at the other property of sine. Sine of an angle is equal to sine of 180 degrees minus that angle. So if we do 180 degrees minus 30, we get 150 degrees. Another angle for which sine is equal to +1/2. So x is equal to 150 degrees plus, we could go any number of revolutions around the circle and find an additional angle. So these are the two solution sets for this equation. Let's take a look at another example. Number 2. Sine of the angle x is equal to -1/2. And we'll take inverse sine of both sides of the equal sign. And inverse sine and sine cancel out. We're left with x is equal to arc sine or inverse sine of -1/2. And we get x is equal to -30 degrees. Now we want to express this as a positive angle. So here is -30 degrees. If we go positively around the circle, this -30 degree angle is equivalent to 330 degrees, positive angle. So we'll express our solution as positive 330 degrees plus any number of revolutions around the circle will give us sine equals -1/2. So this is our first solution set. Now we'll use the sine property. Sine of an angle is equal to 180 degrees minus that angle. And 180 degrees minus -30, we get 210 degrees. And we do see that in the third quadrant, sine is also -1/2 for 210 degrees. So we get our second solution set, 210 degrees plus any number of revolutions around the circle. That'll bring us back to that point. Now let's take a look at a third example. This time we have 3 times x inside the argument for sine. Let's take a look at this. First step, we'll take inverse sine of both sides of the equal sign. Inverse sine and sine cancel out, and we're left with 3x is equal to arc sine of the square root of 2 over 2. And arc sine of square root 2 over 2 is equal to 45 degrees. Now, 45 degrees plus any number of revolutions around the circle. So 45 degrees plus 360n. But that's equal to 3 times the angle. So we have to divide every term by 3 to solve for just x. And we get x is equal to 45 divided by 3 is 15, plus 360 divided by 3 is 120 times n. So this is our first solution set. Now we need to use our property of sine. We got 45 degrees for the principal angle when we solved. So we'll do sine of 45 degrees. Use our property of sine. Sine of an angle, 45 degrees, is equal to sine of 180 minus 45 degrees. Sine minus 180 minus 45 degrees, we get 135 degrees. So 3x is also equal to 135 degrees plus any number of revolutions around the circle. And once again, we will divide every term by 3. And we get x is equal to 135 divided by 3, we get 45 plus 120 n number of revolutions around the circle. Let's take a look at solving a cosine equation. So just as we did with sine, the cosine equation also, as is, does not pass the horizontal line test. We do hit more than 1 point if we use the entire domain. So we will restrict the cosine domain from 0 to 180. So now this piece will pass the horizontal line test. And then the inverse function switches the domain and range of the cosine function. So our domain, any input, inverse cosine of any value needs to be between -1 and 1. And we will get an output of any angle between 0 and 180 degrees. To find all the solutions, we will need to use the other properties of cosine. Let's take a look at an example. Number 4, solving cosine of x is equal to 1/2. We will take inverse cosine of both sides of the equal sign. Inverse cosine and cosine cancel out, and we're left with x is equal to inverse cosine of 1/2. And we get our angle in degrees. X is equal to 60 degrees. Now here again, we can go any number of revolutions around the circle to get back to that point. So we will do plus 360n to get all of the solutions. So this is our first solution set. Let's take a look at the cosine. Oh, I just realized I'm missing the e. Let's put that in there. Cosine property. Cosine of an angle is equal to cosine of negative angle. So x is also equal to negative 60 degrees. But we want to express this angle as a positive angle. So negative 60 degrees. So we'll do 360. This is negative 60 degrees. Negative 60 degrees. So if we go positively, let me use a different color. If we go positively counterclockwise around, we will get 300 degrees is equivalent to negative 60. So we get x is equal to 300 degrees plus any number of revolutions around the circle. Let's take a look at one last example. Last one. Solving cosine of x is equal to negative 1/2. We will take inverse cosine of both sides of the equal sign. Inverse cosine and cosine cancel out. We're left with x. The angle is equal to arc cosine of negative 1/2. And we get x is equal to 120 degrees plus any number of revolutions around the circle that will bring us back to that point. And then we'll use our cosine property. Oh, wow, I was cutting and pasting. I missed the E down here. We'll use our cosine property. Cosine of an angle is equal to negative cosine of the angle. And a negative 120 degrees we'll express as a positive angle. So 360 minus 120, this is a negative 120. So 360 minus 120 will give us the positive angle 240 degrees. And then we'll do plus any number of revolutions around the circle. And we get our last solution set, 240 plus 360. And that concludes solving sinusoidal equations. Thanks so much for joining our session, and I'll see you next time.